When, as I said, I went to Harvard as an undergraduate, and it was wonderful, and I had a neurology lab and a psychology lab, and that was great. Most students never got that, and I happened to be at the right place at the right time. And I was majoring in physics for a while, and my grades weren't particularly good, so I thought I should make up for that by writing a good thesis. And it turned out you couldn't write a thesis in physics. They just didn't have it, bachelor's thesis. So Gleason said, my mathematician friend says, why don't you just switch to the math department? You can write a thesis there. So I wrote a nice thesis about fixed points on spheres. It was pretty exotic. There was an unsolved problem, and I solved half of it. Got some really striking results.
What was the problem?
The problem was, it was known that if you have 3 points on a sphere, suppose you have a sphere, it's like the Earth, it has an altitude. If it turns out that if you take 3 points around the equator, equally spaced, there's some place you can put them where the altitude of all 3 points will be equal. In other words, if you had well, that's the theorem. It was proved by Professor Kakutani at Yale, but it was only true for 3 points on a great circle, and it seemed to me this ought to be true for any triangle. That is, you ought to be able to put it somewhere and rotate it so that, like a three-legged stool, so it would stand straight up. I couldn't quite prove that, but I proved that it was true for several different shapes of triangles. And then I got stuck, and a couple of years later, this strange person I never heard of named Freeman Dyson proved the thing in general, and he sent me this paper, and I didn't believe anyone could possibly be that smart.